After more than 40 years of waiting, a probe specifically designed to find life on the red planet has been dispatched to Mars. Although it has not yet begun its serious scientific work, its intention is to find evidence of past life and hopefully present life as well. But sadly, this probe has arrived too little, too late for this man. Dr. Gilbert Levin, who headed the search for life experiments on the Viking probes back in 1976, has sadly recently passed away. In the year that I've gotten to know him, since I was fortunate enough to interview him, as a matter of fact, I think I may have been one of the last to have interviewed him, he and I corresponded regularly, and I never knew a gentler and kinder man, nor a man who was more intelligent. And his colleague, Dr. Patricia Straat, who shared his views that life was discovered on Mars in 1976. I had an opportunity to interview her, but squandered it, feeling that two back-to-back interviews about life on Mars would not go over very well, and she passed away before I had a chance, and I will curse myself forever for that decision. But there is hope. More advanced versions of Dr. Levin's experiments, his label release experiments, and others that discovered life on Mars, not only on Viking 1, but Viking 2, to a great degree of certainty as far as I'm concerned, have now been approved for a future mission. And this mission, according to information that's been provided to me by one of Dr. Levin's colleagues a couple of days ago, will be partially at least funded by Elon Musk. So it is possible that at least soon after his passing, he will see his discoveries realized and recognized, because it is my firm belief that given the scientific evidence that I've presented in a number of videos in the past, that Dr. Levin and Dr. Straat unquestionably found bacterial life or evidence of such life on Mars at Viking 1 and Viking 2. And all we have to do is look again, and we will certainly find it again, hopefully with more advanced instruments. Most popular, I think, of these new instruments is the Ingenuity helicopter, a device that's really kind of a proof of concept helicopter designed to fly in the thin Martian atmosphere. It's an amazing piece of technology, especially when you consider that Mars's atmosphere is less than 1% that of ours, and yet this thing has completed 10 flights at the time of this recording and doesn't show any signs of letting up. This is the kind of device that might be able to fly into shadowed nooks and crannies, place where life might be able to hide from solar radiation, solar storms, etc. Something that might be able to finally vindicate Dr. Levin and his colleagues. But is this the best way? Are there other ways that we can travel across the red planet, soaring through Martian skies? Well, as a matter of fact, there is, and I'm going to tell you all about it in just a moment. Good evening and welcome to another episode of the Angry Astronaut, part of a 1-2 punch again that I tend to do over the weekends, a live stream along with a recorded episode. So this one is going to be about a slightly different topic. By the way, I am aware that I have a third part of the new space race still to come, so bear with me, I'm getting to that one. There have just been some other topics that have been coming up, things that I've been wanting to talk about, and I haven't been able to talk about, mostly because of Blue Origin and Jeff Bezos. I think that is largely at an end simply because the GAO has made their decision, and I had a live stream about that particular topic, so I don't have to make a video on it. I didn't want to make a video on it, so moving on until he pulls something else, which could be tomorrow for all I know. Anyway, Ingenuity, that's what I want to talk about primarily. I mean, so far, this little helicopter has performed far above expectations. I mean, it's the little helicopter that could. It was intended for only 5 flights. It was essentially a proof of concept design, and instead this thing has taken 10 flights at the time of this recording, and it's probably likely to do some more. So it really has accomplished a lot more, even than I thought that it would. And the reason that I had some doubts about it was simply because of the nature of the Martian atmosphere, because it is so incredibly thin, less than 1% of the density of our own atmosphere. The whole concept of a helicopter seems out of place. It just doesn't seem rational. It relies obviously on the presence of an atmosphere in order to be successful. Helicopters can't even go to certain altitudes on our own planet without, not being functional. They're subject to all kinds of adverse atmospheric conditions, that sort of thing. It just didn't seem practical to me to put a helicopter on a planet with such a thin atmosphere. But guess what? NASA found a way to make it work, and I'm glad that they did, and it has accomplished a great deal. And now they have plans, as you saw in my brief introduction, to do more with this thing, to expand it, to make it more ambitious, to have it carry more equipment, a greater range, that sort of thing. But is this the only way to move forward if we're talking about transportation on the red planet? If we're talking about aerial transportation in any event, is this really the best way for us to do it? Now, obviously, Ingenuity has proven itself, but how much cargo can something like this really carry in such a thin atmosphere? What are the limitations? And is there a better way? Is there a way to travel through the Martian atmosphere without using rockets that could carry a substantial amount of cargo from place to place without using some sort of mega helicopter with a tremendous power source? Well, as a matter of fact, there is, and it involves stepping backward technologically, but maybe not stepping so far backward, because where it gets us in terms of our mobility on Mars is a huge leap forward. And we're going to find out all about that right now. I must confess, the first time I saw this thing fly, I was like, seriously? An arthritic grasshopper could do a better job. Why didn't they just make something with powerful legs or something that could crawl up the side of a mountain or something like that? I mean, this isn't going to be able to do any good. Well, of course, like just about any other idiotic observer, I did not realize that this was just the beginning of this thing's capabilities. Yes, it only climbed to a height of about 3 meters, and it maintained a stable hover for about 30 seconds. The total flight time is 39.1 seconds, hardly enough time to do anything useful. But by the 5th flight, things had changed quite dramatically. The Ingenuity team was becoming ambitious. They had already achieved the 5 flights, or they were on the 5th flight anyway, that they had anticipated, and there was no sign that this piece of equipment was going to break down anytime soon. So they dared to hope that they could achieve something a lot more impressive, and they did. The chopper, weighing only 1.8 kilograms, by the way, climbed to an altitude of 5 meters this time, cruised south for 129 meters, following the same path actually that it had taken on its 4th flight, but the difference is this time they decided to land it at a different location. It was a one-way trip, so it climbed up to 10 meters, twice as high in the sky as it had gotten before, snapped some photos, and landed in a new place with a 108-second flight. What this demonstrated, of course, is that Ingenuity could not only ascend to a certain height, take a few photographs, and then return to base, but could actually travel bit by bit across the Martian surface far faster than any rover could, and gather data in the process. Now, the current Ingenuity can only gather so much information, but future versions of this helicopter will be able to acquire a lot more information, and from areas that are very difficult to get at. This is a remarkable little spacecraft, but it wasn't done yet. Flight 10 was the most challenging yet. The copter had to fly over 10 different waypoints in an area that's called the Raised Ridges Target, an area that NASA intends to send Perseverance at some point. It achieved a maximum altitude of 12 meters, a new record height. It flew about 95 meters, and from takeoff to landing, the entire flight lasted just under 3 minutes. A tremendous leap from the first flight, and it gained a lot of important information, something that previous rovers have not had. So rovers have had to go to certain areas on best guesses and satellite imagery. This is far more precise and will allow rovers to function far more efficiently. However, in order to keep this thing aloft, it has to spin its rotors at 2,400 revolutions per minute at a speed of 70% of that of sound. And even then, it can only stay aloft for a few minutes and carry about 2 kilograms per flight. It's simply not enough. Now, they have an upgraded version in the works, but even that, in spite of its much larger size and larger number of rotors, can manage 10 kilograms. This is not a vehicle that's going to be transporting humans or even large amounts of cargo from place to place on Mars. But you might say, why do we have to fly through the air? We can use the Boring Company, we can use trains, we can use subsurface Teslas. Well, that's true, but if we give up aviation, we're kind of taking a step backwards. Wouldn't it be better if we had the ability to travel from place to place on Mars? Well, this is the answer: a Martian dirigible. Now, this may seem impossible given how thin the Martian atmosphere is, but actually it is not. There are a couple of different ways to make a Martian dirigible or a Martian Zeppelin a reality. And not only would they be a reality, they could carry substantially more cargo for a much longer distance than any version of the Ingenuity could. And this is simply because there's a way to make this balloon lighter than the atmosphere around it. This may seem ridiculous given how thin the CO2 atmosphere is, but we also have to remember just how heavy CO2 is as a molecule versus other types of gases that we might use. For example, let's compare CO2 to hydrogen. CO2 is a surprisingly heavy element, with 2 oxygen atoms at 16 atomic weight apiece and a carbon atom at an atomic weight of 12, whereas hydrogen has an atomic weight of 2 with 2 hydrogen atoms. This means that you could fill up a Martian dirigible with an atmospheric density of 10% of that we have on Earth, of course comprised of hydrogen, and it would be able to float. 10%, which would not be all that difficult really, and if you pumped in less, it would be able to float even better. Some have suggested not using hydrogen or any other kind of gas at all, but rather creating a complete vacuum inside the balloon, which of course would be able to float ideally. But as it has been often said, nature abhors a vacuum, and it might be a lot more difficult from an engineering perspective to create something like that. And hydrogen is very abundant on Mars. There's far more water than most people give it credit for. Many people have estimated that there is enough water in the polar ice caps alone to submerge the entire surface of the planet in at least 1 to 2 meters of water. But I mean, is this light enough? I mean, isn't even 10% hydrogen inside of a balloon not sufficiently light in order to overcome the incredibly thin nature of the Martian atmosphere? Well, yes, it absolutely is, and we have a company that intends to do just that here on Earth. You may have heard of these guys. They're called Space Perspectives, and they intend to provide a kind of space tourism without actually going to space. No microgravity or anything like that, but still an unbelievable view of the Earth and for an unparalleled amount of time. And these guys can carry not only passengers, but a bar and other amenities for their guests for a very long stay, getting a magnificent view of our home world. And this vessel is carried by a balloon loaded up with, you guessed it, hydrogen. If it works at an altitude of 30 kilometers, where the atmosphere on Earth is substantially thinner than it is on Mars, then the same thing could definitely work on Mars as well. Now here's a disturbing question. Hydrogen gas, isn't that the same thing that they used in Zeppelins and on the Hindenburg? I mean, aren't we taking a tremendous chance repeating history here? Well, there's an important difference. Hydrogen will not catch fire without an oxidizer, in other words, without oxygen. So although oxygen in the cabin theoretically might be able to create a fire of some kind, there could probably be some sort of emergency system designed to evacuate the oxygen from the cabin whilst providing emergency oxygen to the passengers without creating a disaster such as this. This sort of thing simply cannot happen on Mars for the same reason that Mars is so lethal to us atmosphere-wise. Not enough oxygen, not enough potential for a fire. And this balloon, designed to test the viability of an inflatable heat shield, went even higher, where the atmosphere is substantially thinner than most of Mars. Now granted, there are some areas of Mars, say at the top of Olympus Mons, where this might not be practical, but for the majority of the planet, this would be an ideal solution. It could carry so much more cargo, and it wouldn't be subject to Martian weather very much, again because of the thin atmosphere. Thin atmosphere means very very, very weak wind that would hardly have an impact on a balloon's trajectory. The only danger I can think of is a dust storm, which tend to be loaded with electrostatic charges, including lightning, and would also accumulate regolith on the balloon, increasing its weight and causing it to either descend or perhaps crash. But other than that, I see this as being an extremely viable way to explore the red planet using aviation. And this is something that really pisses me off. Why was a proof of concept of this type of technology not included on the Perseverance? I mean, I love the Ingenuity, but this thing has so much more when it comes to capability and its ability to haul a larger amount of mass. For that matter, why was the Moxie included? Converting water into usable oxygen and hydrogen is estimated to be 10 times as efficient. Why do we bring second-rate experiments on this extremely important mission when we could have brought something that could have made staying on Mars and a sustained presence on Mars a reality? Now we need to redo our work again, depending on when another mission is coming up. We simply don't have that kind of time, at least on Elon's timetable, and that is simply unacceptable. Our next probe, whenever it comes out, needs to be more practical. I'm all in favor of what just happened with Ingenuity. I think it's remarkable, but at the same time, is it practical? For some things, perhaps, but overall, there are better solutions. And by the way, none of the experiments on the Perseverance are specifically designed to detect living organisms. They are instead designed to detect evidence of past life. Any study involving living organisms is going to have to involve a sample return mission back to Earth, a mission that's at least 10 years in the future, which means Dr. Levin and his colleague Patricia Straat are not going to see their dreams realized, wherever they are, for at least another 10 years. We can do better. We're just not. So, it is indeed, as you've seen in the video, a bit of a step backward. We're going to dirigibles again, dare we say it, to Mars Zeppelins. And that kind of has a negative connotation, of course, because of the Hindenburg. But, as we saw in the video, because of the lack of oxygen, hydrogen is not, fuel is not going to, present any fire danger on Mars. So, filling up a balloon with hydrogen is not going to present any sorts of issues. Now, of course, it's not going to be a great deal of hydrogen simply because the Martian atmosphere is so incredibly thin. But in my opinion, it's going to be easier to do things that way than to try to create a vacuum inside, a balloon. I think that it's possible. I just think that it could be a little bit more dangerous. Anytime you create a complete vacuum inside of any space, you are subjecting, given space and the area around it, to a substantial amount of pressure. And, if the fabric or whatever's holding up the balloon fails to take the pressure for some reason, then you have a real problem. Hydrogen, on the other hand, of course, is the lightest substance in the universe. And even though the Martian atmosphere is incredibly thin, carbon dioxide has a very high atomic weight. And so, therefore, a hydrogen balloon would work on Mars as long as it was a fairly small amount of hydrogen present, and the potential potential is tremendous. Instead of carrying tiny cargoes using, rotor blades that are spinning thousands of times per minute, for short distances, a few hundred meters, that sort of thing, we could be looking at vessels that could ply the skies of the red planet, carrying human passengers and cargo from place to place over thousands of kilometers instead of just a few hundred meters. I do feel that the Ingenuity type solution has a role to play, rather, in the exploration of Mars. I think for, short distance scouts, that sort of thing, that, these sorts of helicopters definitely could be quite useful. They've already proven themselves, and, upgraded versions could definitely do more. I think that there is a role for them to play, but I don't think that it's the only solution. And since they've already proven that they can lift a vehicle using very fast spinning rotors, they would also be able to push a vehicle such as a dirigible using very fast spinning rotors. If you're not having to oppose gravity, then the ability of these rotors to push a large amount of mass through the Martian atmosphere just simply becomes that much easier. In my opinion, this is something that needs to be explored. I am a bit disappointed that a proof of concept of this type of design, just a small balloon filled with hydrogen and a tracker on it, wasn't released, and we just see what happens to it. Does it float to the ground? Does it float across the Martian atmosphere? How much effect does the Martian wind have on it? All of that would have been a very cool thing to put on this probe. Of course, it only had so much room. I do understand that concept, but still, I think it's something that we urgently need to do, especially considering that Elon has such an aggressive time frame when we're talking about taking humans to Mars. All of the different options to make establishing colonies on the red planet easier need to be explored, utilizing robots first before we risk astronauts. And the clock is ticking as far as Elon is concerned. We're only talking maybe 10 years max, and really he wants it, I think, to be sooner than that. So there needs to be additional probes sent, additional unmanned craft with more, proof of technology types of devices to make our ability to establish a self-sustaining colony on Mars a reality and make us into a truly interplanetary species. If you like what I have to talk about, if you like the fact that I take on one of NASA's most successful projects and criticize it, which is not something I really wanted to do. I think Ingenuity has, been a huge success for what it is. But if you like the fact that I think outside the box and present other ideas that others have presented in the past, this certainly isn't my idea. You know how to support me. It's all in the description, many different ways, or you can just pound that join button or just hit subscribe and like, and I will be very happy. So until we have explored every possible way to transport the human species quickly, efficiently, and safely across the red planet in order to establish colonies, not just in one area, not just in one space, which was going to make us vulnerable, but rather all over the planet so that we can sustain our presence there forever. Until we do this, I urge all of you to stay angry about space.